welcome you all to Think Maths. We are in class 10 Maths, chapter 10, circles. In this session, we are going to discuss about the example problems 1, 2 and 3. Example 1. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. Here what is given? There are two concentric circles. What do you mean by concentric circle? So concentric circle means from the same center point, circles will be drawn. So this is the center point. From this center, its radius is here. So from the same center, if we extend the radius, another circle. And these two are called concentric circle. So center point will be same for concentric circle. So these two are concentric circle. Here what is given? The chord of the larger circle. So and this point is called this line. This line is called the chord. What do you mean by chord? So if this is a circle and if it meets the 2 points in the circle and this line is called a chord. So chord does not pass through the center. So if it passes through the center, it is called diameter. So this PQ is the diameter. So diameter will pass through the center and chord will not pass through the center. So here this line is the chord for the larger circle which touches the smaller circle. So it touches the smaller circle C1. What we have to prove is bisected at the point of contact. So this line is divided into two halves. Bisected means this line is divided into two halves. Okay. So these are the things given. So first let us name everything. Okay. So here O is the center and P is the point of contact and AB is the chord. So there are two circles C1 and C2. So C1 and C2 are two concentric circles with the same center O. And AB is the chord of circle C1. So C1 is the larger circle. So it is given that chord of the larger circle. So AB is the chord of circle C1 and P is the point of contact. So point of contact touches the smaller circle. Okay. So P is the point of contact for the smaller circle. What we have to prove? We have to prove this chord bisects at the point of contact. That is AP value and PB value is divided into equal half. AP will be equal to PB. That is we have to prove. So and we are going to construct two lines. We are going to join OA and OB. So let us join this. Join OA and OB. Okay. So now what we are going to prove? We are going to prove these two triangles OPA and OPB are congruent. So if we prove, then their corresponding sides will be equal. Okay. So here what we know? We know OP. OP is the center of the circle C2 and P is the point of contact in the circle. Then OP will be the radius. So OP is the radius and this line AB is the chord for the larger circle and AB will be the tangent for the smaller circle because AB touches the small circle at only one point P. So AB will be the tangent. So let me start the proof. So here OP is the radius and AB tangent of C1, small C2, small circle is C2. So tangent of C2. Okay, children. So then we know that tangent and radius make 90 degree. So OP is perpendicular to AB. This is because by theorem 10.1. So radius and tangent are perpendicular at point of contact. So this is theorem 10.1, which we studied in the previous video. So OP will be perpendicular to AB. So this angle will be 90 degree and this angle OPB will be 90 degree. So let me choose the triangles OPA in triangle OPA and triangle OPB. So what are the things we have? We have angle OPA equal to angle OPB. Both are 90 degree. These things we know. Next, what about OA and OB? OA, OB. So this O is the center of circle C2 as well as C1. As C1 and C2 are concentric circles, they have the same center. So OA is nothing but from the center to a point on circle C1. And OB from the center to the point on circle C1. So both are radius of circle C1. So both their radius will be same. So OA will be equal to OB. This is because radius of larger circle C1. Next OP. OP is common for both the triangles. So OP equal to OP. So this is because common. Now we have a right angle. So for 90 degree, its opposite side, this is the hypotenuse. So this is hypotenuse side is equal and one side is equal. That is RHS. So we can say triangle OPA is congruent to triangle OPB. So by the criteria RHS. Okay, right hypotenuse side. So this is by previous classes. Now we have triangle OPA congruent to triangle OPB. Then what will happen there? Corresponding sides will be equal. So we have PA equal to PB. So we have PA equal to PB. Or we can write AP equal to BP. So this reason is CP, CT. Corresponding parts of congruent triangles are equal. So that is what we have to prove and we have proved it. Okay children, do you understand this example? So moving on to the next example in the next page. Example 2. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ equal to 2 times angle OPQ. So here what is given? So there is a circle. It has the center O. So there are two tangents TP, TQ. So P is the point of contact and T is the external point. So these are the things given. We have to prove PTQ is equal to 2 times angle OPQ. Okay. So let us start this solution. First let us write what are all given. So what are all given here? O. O is the center of the circle. This is given. Then TP and TQ are tangents to the circle with point of contact P and Q respectively. So these are the things given. Okay. So this T is an external point. So external point means it is not in the circle. So it is outside the circle. T is an external point. What we have to prove? We have to prove angle PTQ equal to 2 times angle OPQ. Okay children. Now let us start the solution. That is proof. What is given here? TP and TQ are tangents from an external point. So we know from theorem 10.2 the tangents will be equal in length. So we can write TP is equal to TQ. The reason is lengths of the tangents from an external point are equal. This is by theorem 10.2. Okay, so TP is equal to TQ. Then what will happen? The angles opposite to this will also be equal. So what is the angle opposite to TP? So the angle opposite to TP is Q. That is angle TQP or PQT. Okay. So angle opposite to TP is angle PQT will be equal to, so who is opposite to TQ? So opposite to 2Q is, it is P. So it is QPT. So angle QPT. That is angles opposite to equal sides are equal, which you have studied in previous classes in 9th standard. So angles opposite to equal sides are equal. So PQT will be equal to QPT. Next one, OP. Who is OP? OP is the radius and TP is the tangent. So we have OP perpendicular to PT. This because radius and tangent are perpendicular at point of contact. So OP perpendicular to PT. That means angle OPT will be 90 degree. Angle OPT is equal to 90 degree. So let us assume this angle OPQ as theta. So let angle OPQ is equal to theta. Okay, children? So these are the assumptions and we got angle OPT is equal to 90 degree. Okay, children? So let us do the remaining calculation in the next page. So far we have assumed these things and we got angle OPT is equal to 90 degree and we have assumed angle OPQ as theta. So this angle is theta and we have assumed. Now what about this angle? That is angle QPT. So this whole angle is 90 degree. So this whole angle is 90 degree. So we can say angle QPT plus angle OPQ will be equal to 90 degree. We have angle OPT as 90 degree. So OPT can be written as OPQ plus QPT. So we have angle OPT is equal to 90 degree. So OPT can be written as angle OPQ plus angle QPT, which is 90 degree. And we have assumed OPQ as theta. So theta plus angle QPT equal to 90 degree. So we will get angle QPT is equal to 90 degree. This plus theta will become minus theta. So angle QPT is equal to 90 degree. So this is 2. So we can write it as from 2. Okay. So this equation is 1. Here we have angle PQT and angle QPT are same because angles opposite to equal sides are equal. So as we got QPT is equal to 90 minus theta, then PQT will also be the same because both are QPT and PQT are equal. So we can write angle PQT is also 90 minus theta. So by equation 1. Okay, children. So these are the things we got. Now I am going to take the triangle TPQ. So in triangle TPQ. So we will take PTQ. What do you know? If you add all the angles in a triangle, it is summation is 180 degree. That is angle sum property in a triangle. So angle PTQ plus angle TQP or PQT. So this angle PQT, this angle, next QPT. Angle QPT is equal to 180 degree. This is angle sum property. So if we add all the angles, we will get 180 degree. We don't know what is PTQ. So keep it as such. What is PQT? PQT is 90 minus theta. 90 minus theta. What is QPT? It is also 90 minus theta. It is equal to 180 degree. So let us keep this as 3. So this is from 3. So angle PTQ plus add both 90. 90 plus 90, it is 180. Add both minus theta and minus theta. So minus theta is minus 2 theta, which is equal to 180 degree. So angle PTQ will be equal to, here what we have, 180 degree. Bring everything to this side. So plus 180 will become minus 180. Minus 2 theta will become plus 2 theta. So this gets cancelled. So angle PTQ is equal to 2 theta. So angle PTQ equal to 2 theta. What is theta? Theta is nothing but angle OPQ. So instead of theta we can write OPQ. So this is from 2. So this is what we have to prove. So angle PTQ is equal to 2 times angle OPQ. So and we have proved it. Okay children, do you understand? So moving on to the next example. Before that, just check out my channel about the playlist. Hi friends, this is my YouTube channel Think Maths. If you like my videos, just show your support by subscribing to this channel and hit the bell button so that you get the notification whenever I upload my videos. So these are the playlist in my channel. So if you want, you can check out the playlist. So there are some playlists on Class 10 Maths, Chapter 9, some applications of trigonometry, and you have all the playlist for sample question paper, and this is the playlist for Introduction to Trigonometry. In the same way, there are playlists for each chapter for Class 10 Maths, and also there is a playlist for Math Olympiad questions. So if you want, you can check the playlist. Thank you. Example 3. PQ is a chord of length 8 cm of a circle of radius 5 cm. The tangents at P and Q intersect at a point T. Find the length TP. So here there is a chord. So chord means it passes through 2 points in the circle. So it doesn't pass through the center. So this point O is the center and this is the chord. So there are 2 tangents here. So these are the things given. So let us mark all those things. So here PQ. So PQ is the chord and O is the center. So we have assumed let O be the center of the circle. It is given PQ. So PQ length is 8 cm. So PQ is the chord. It doesn't pass through the center. So PQ is the chord and its length is 8 cm. The tangents at P and Q. So at P and Q, there are tangents. It intersects at a point T. So it intersects at a point T. We have to find out the length of TP. Okay. So PQ is a chord and its value is 8 cm and OP. So from the center to a point in a circle makes radius. So radius is given as 5 cm. So OP will be 5 cm. This given TP and TQ are tangents to the circle. from an external point T. So we have to find TP. So now we are going to construct TO. So that is, we are going to join T and O. So join TO to meet PQ at R. So let us mark this point as R. So these are the construction. Okay. Now we have TP and TQ are tangents. So we know that tangents from an external point are equal. So TP will be equal to TQ. The reason is tangents from an external point are equal. Okay, so this is theorem 10.2. So if these two are equal, then we can say if two sides are equal, then we can say triangle TPQ is an isosceles triangle. So triangle TPQ is an isosceles triangle as two sides are equal. Okay, so this is isosceles. So isosceles, and there is a line TO here. So if this is isosceles, here TP and TQ are equal. So if TP and TQ are equal and this angle TQ opposite is P and TP opposite is this angle. Their angles will be equal. So these two angles will be equal. So if we draw a line from this vertex, so this point is the vertex of the isosceles triangle, then this line will be the angle bisector. So this is the isosceles triangle property. So TO will be the angle bisector. Angle bisector means this TO bisects this angle. So this angle will be into 2 equal half. So TPQ is an isosceles means this implies TO is the angle bisector. If TO is angle bisector, then this TO will be perpendicular to this chord. TO will be perpendicular to this chord. So TO perpendicular to PQ. So this angle will be 90 degree. Okay. So angle TPO or angle TPR, not TPR, TRP will be 90 degree. So this angle will be 90 degree. Okay children. So if this is 90 degree, from example 1 we know that if this is the perpendicular and PQ is the chord, this perpendicular will bisect the chord. So this is from example 1. So this R, so this is the line PQ and this is the point R and OR. So what happens? OT is perpendicular to PQ. So OR also will be perpendicular to PQ. So if this is so, this OR will bisect PQ. So RP length and PQ length will be equal and it will be 2 equal half. So PQ is equal to 4. So then RP will be 4 centimeter, 4 centimeter because 8 by 2 is 4. So this RP length will be 4 centimeter and this length will be 4 centimeter. Already we have OP is equal to 5 centimeter. Okay children. So we have, so this implies PR equal to QR equal to 4 centimeter. Okay. Now we are going to prove the triangle TPO, which is right angled at TPO. So because radius and tangent make 90 degree. So angle TPO is equal to 90 degree because radius and tangent make 90 degree. So and we are going to prove triangle TPO and triangle PRO are similar. Okay. So if we say prove similar, then their corresponding sides will be proportional. From that we can find out the value of TP. So to find out the value of TP, we should know what is RO. Okay. Now take the small triangle. So in triangle, that is in right triangle PRO. Okay. So this is the small triangle PRO. PRO. So here OP is 5 centimeter and PR is 4 centimeter. So it is right angled here. Now this is the hypotenuse side. We have by PGT OP square will be equal to OR square plus PR square. What is OP square is 5 square. OR square we need to find. PR square is 4 square. So it is 25 equal to OR square plus 4 square is 60. So 25 plus 16 will become minus 16 equal to OR square. So 25 minus 16 is 9. So 9 is equal to OR square, or we can say OR square equal to 9. So taking square root on both sides, this root and power 2 gets cancelled. So OR will be equal to square root of 9 is 3. So OR is equal to 3 centimeter. So we got OR is equal to 3 centimeter. Now we have to find out TP by proving this triangle TPO and triangle PRO similar. So if you prove by sides are proportional, we can find out the value of TP. We will do that in the next page. So from the previous page, we have OR, which we found by PGT as 3 centimeter and PR is equal to 4 centimeter, OP is equal to 5 centimeter. So these are the details we got from the previous page. So now take this triangle OPT. This triangle, that is OPT. Here OP is the radius and TP is the tangent. So we know from theorem 10.1, tangent and radius make 90 degree at the point of contact. So OP will be perpendicular to PT. So because radius and tangent are perpendicular at point of contact. So this is theorem 10.1. So this angle OPT will be 90 degree. So this triangle is drawn here separately. So angle OPT is equal to 90 degree. So now let us choose the triangle. This big triangle OPT and triangle ORP. So in ORP, because this is an isosceles triangle, we got TO as the angle bisector. Then this line will bisect PQ. These are all from isosceles triangle property. So this angle will be 90 degree. That is angle PRO will be 90 degree. So this angle is 90 degree. So we are choosing these two triangles. In these two triangles, we have OP is equal to 5. In the small triangle, we have PR is equal to 4, OP is equal to 5 and RO is equal to 3. Okay, so these are the details we got from the previous pages. Now in triangle OPT and triangle ORP, who is 90 degree? Angle OPT, and in this triangle it is ORP. So angle OPT equal to angle ORP. Both are 90 degree. Next, what about this angle O? Both are common. So in this triangle, angle O, and this is also a full angle O. So angle O. So in this triangle TOP, in this ROP. So T and R in the same line. So angle O is common. So as two angles are equal, we can say triangle OPT similar to triangle ORP by the criteria angle criteria. Okay. So here O is common, angle P is equal to angle R. So after P, you should write R here with the remaining T in this, P in this. So triangle OPT similar to triangle ORP. So then their corresponding sides will be proportional. So OP, OR. OP by OR will be equal to PT by RP, which will be equal to OT by OP by OP. So what are all the things we know? We know OP is 5 centimeter, OR is 3 centimeter, and we know this we have to find out length of PT. So we have to find out this. So what is RT? RT, what is the value of RT? We don't know. So let us take, where comes RT here? It is not RT, I'm sorry. You have PT, here it is RP. Okay, so PT, in this it is RP. What is RP? RP is 4. So this is also no. Okay, so let us choose these two ratios. OP by OR equal to PT by RP. What is OP? OP is 5. OR, it is 3. PT, we need to find out. What is RP? RP and PR are same. It is 4. So just cross multiply 3 into PT. 3 into PT will be equal to 5 into 4. 5 into 4 is 20. So PT will be equal to 20 divided by 3 centimeter. Okay. So PT value is 20 by 3. So length PT or TP both are same. So length TP is equal to 20 by 3 centimeter. Okay children. Do you understand? I hope you can understand all the examples. If you like the video, just show your support by subscribing. Thank you. Thank you for watching.